Hi, I'm Valdis from Bloom's Tutoring, and today we are looking at Surds. So, going off the QCAA standards, specifically the ones for Math Methods 2025 Queensland, this topic should be taught across, should have effectively 4 hours of teaching and learning for this topic. So, roughly four of your 70-minute lessons in class. So let's go over what should be taught and dive into some questions about this content. Now, a lot of this was covered in year 10, so I'm not going to go through all of the basics in great depth. Instead, I'm going to focus mainly on the extension, getting us up to what should be considered mainly about year 11 standards. So if I just jump over to um, my written page here for a second, I've written out three kind of questions that I think you should be able to do with year 11 math. So there's a bit of algebra involved, but these are all still surds. So you have surds effectively being square roots, things that can't be represented as whole numbers and fractions. And so you've got a square root component. And that's roughly what a surd is. Now, you also need to look at radical signs. So what do I mean by radical signs? Is higher order surds. So taking the fourth root of something. On top of that, you need to be able to rationalize the denominator. So in class, you may have just had a square root on the denominator, not being multiplied by something. So we'll have to go over what to do there. And then what happens if you've got, instead of multiplication between some stuff on the bottom, you've got addition or subtraction. So you've got a larger chunk of stuff on the bottom as well. Now, if you're looking at these questions and you can answer all of these, then it's probably okay to skip these surds tutorial classes and dive straight into the quadratic section. So if I just jump back over to the screen, we'll have a look at what other concepts you're supposed to be able to do as well. So understanding that they're rational numbers, simplifying, so being able to pull numbers out of the square roots, all that should be okay, hopefully from year 10 content. Then rationalizing the denominator, as I just said, and also using the four kind of signs, so addition, subtraction, multiplication, division. So we'll go over some of the year 10 content just briefly, just to touch base, get a bit of a refresher, and then we'll go into some more of the harder content. So if I have addition and subtraction of surds, let's say I've got 3 square root 5 plus 2 square root 5 minus 1 square root 5. And let's say all of that is divided by square root 5. And this is also multiplied by square root 2. So let's say I have a question like this. So we're covering all four aspects of the symbols. So we've got addition, subtraction, we've got multiplication, and we have division. So let's start with the stuff in the brackets here, and let's try and simplify this part. So if I just write out this section separately over here, so you have 3 square root 5 plus 2 square root 5 minus 1 square root 5. And we're simplifying this. We have a square root 5 in each term. So because we have the same component in each term, it's kind of like saying I have 3 apples plus 2 apples and I'm minusing 1 additional apple. How would we do that mathematically? Well, we would factorize out that square root 5 and then we'd write it as 3 plus 2 minus 1. So we have that section of stuff equal to 4 square root 5. Now, going back to this question up here, I'm just going to substitute in this 4 square root 5 as this whole bracketed section. So we have 4 square root 5 We're multiplying that by square root 2 over square root 5. Now, when you're looking at the algebra side of things, when you only have multiplication and division, order doesn't matter. So we can say, okay, these square root 5s can divide out, and we'll be left with 4 square root 2. Now, just to make that more clear, I'll do a little example off to the side here, and then we'll come back to surds. So for instance, if I had the number 12, the number 12 could also be represented as 3 by 4, which could also be represented as the 3 might be 6 on 2 by 4. So if you were to type all that into your calculator or figure it out, well, that's still equal to 12. Doesn't matter what order you do it in. Okay, so let's look at another revision type of question that focuses on multiplication and simplifying surds that contain perfect square factors. So let's say we have the square root of 3x cubed y multiplied by the square root of 12x y5. Now, have a quick go at this one first. I'll wait like 10 seconds, pause the video, see what you get, and then I'll go through it. Okay, so hopefully you had a chance to give it a go. Now, because we have multiplication of two square roots, we can just bring the square root over everything, or take everything under the one square root. So we have 3x cubed y by 12x y 5. Now, you could go 3 times by 12 to get you to 36, but it's sometimes easier to keep the numbers smaller to see what you can pull out. So instead of combining them to a larger number, let's actually break 12 down to see if we can pull anything out. Because once you combine stuff, you get to different numbers and different factors come out of them. So with the factors of 36, we would have ended up with 3 times by 4. But by just breaking the 12 into 3 times by 4, we remove that additional step of combining and then refactorizing. So we then have x to the 4 and y to the 6. So remember, with your index laws, when you're having multiplication, it leads to addition of the powers. So we have 3 squared effectively. Now, what's happening when you pull something out of a square root symbol? So if I have 3 squared all within a square root, when I convert the square root into a power, that is the denominator in the fraction of the power. So that becomes 3 squared over 2. So that square root is the denominator in that power. And then 2 divided by 2 is 1, so you're left with just 3. Okay, so we now have 3 square root 4x 4y6. And we can do the same stuff to the x to the 4, the y to the 6. 4 is actually a perfect square as well, so we can pull that one out. So when the 4 gets pulled out, it becomes a 2. Now, x to the 4, that's x to the 4 over 2, and y to the 6 over 2. Now I have 6, x, 2, y, 3. Okay, in this particular example that I just went through, it happens that there were no numbers left in the square root. And so it would have been just as easy to combine that into 36 and then see that, okay, that is a perfect square of 6. But when you don't always get it equaling a perfect square, breaking it down into the smaller components can be an easier approach. Okay, next up, let's look at rationalizing a denominator. Now, again, hopefully you've already seen this in class, and this is just a revision. So I've written out this question. I'm gonna pause here for 10 seconds again. Pause the video, have a go at this question, and then we'll go through it again. Okay, hopefully you have had a chance to go through that now. So when rationalizing the denominator, we want to effectively get rid of this square root on the denominator. So how do we do that? We do that by multiplying the whole fraction by that square root. Now we can't just change the value of something. So instead, we're multiplying it effectively by 1 because the same thing divided by itself is 1. So we're not changing its value, we're just changing its representation. So we're allowed to do this. So you have square root 3 times square root 3. You end up with 3 on the denominator. And then you have square root 3 multiplied by this chunk of stuff on the numerator. So hopefully your next step was to expand the brackets. Now, you may have done this all in one step. Okay, I'm just taking more steps to help show everyone what's going on. So you got square root 3 times by square root 6. Let's just bring them all under the same square root symbol. So 3 times by 6. Same thing with the 12 as well. 3 times by 12. Now, I could combine these together to get 18 and 36, but it may not necessarily be the easiest approach. Now, it just happens in the last example, we saw that, well, 36 is a perfect square. So it probably was easier just to combine that one. But maybe we break this one up into 3 times by 2 for the 6. Okay, so we can see working with smaller numbers, we can pull out a 3. Square root of 36 is 6 over 3. Now, hopefully you're able to get to this point here. Uh, if this was your final answer, let's just say that we can actually simplify this a little bit further. So if this was your final answer in an exam, you might not get the marks for it because it's not in its simplest form. So let's look at simplifying this. Now 6 is 3 times 2. You have a 3 down here and you have a 3 up here. So let's just write all those 3's out. Now, when you're simplifying a fraction like this, some of you might think that you just divide one of the 3's out, but you have to divide out a common multiple. So what you're actually doing is factorizing the numerator and then dividing out common multiples. And so your end answer for this question will just be square root 2 plus 2.